So now we going to different Q factors which are possible for a tank circuit. So when you are not going to connect your tank circuit to any external circuit or load, that quality factor you call it as unloaded quality factor. Loading means you are connecting this tank to another load, okay, using a transformer. So when you are not doing that, the tank circuit is not loaded, so it is called as unloaded Q, represented by QU. So in practice, the tank circuit will be connected to a generator under load mostly. So energy dissipation we have to consider. Take into example the energy dissipation happening in the load plus energy dissipation happening in the tank circuit. So that quality factor will be called as QI. That quality factor will be called as QI, and QI is given by max 2 pi into maximum energy stored per cycle by maximum energy dissipated per cycle plus energy dissipated because of external load. If this is because of your tank circuit, this is because of your load circle or external load, whatever you are going to connect. If this load is not there, you call it as unloaded QU. If that load is connected, you call it as loaded quality factor. They call it as QI. Some books refer it as QL. Both are correct. Okay, unloaded and loaded difference you should know. So unloaded means your tank circuit is not connected to an external load. Loaded means either your tank is connected to a generator or your tank is connected to a load. So in that case, the Q factor expression will be changing slightly. So it will include the energy dissipation happening because of the external load also. Okay, so please understand this. And generally, the relation between F naught Q and bandwidth is given by bandwidth equal to F naught by Q, or Q is equal to F naught by bandwidth. So this is the relation which will help you to solve many problems in the tuned amplifier. The bandwidth and quality factor are inversely proportional because F naught is a constant. For a given frequency of operation, F naught will be constant, right? The bandwidth and quality factor are going to be inversely related. So you see here, Q and bandwidth are inversely proportional. So for higher values of Q, the bandwidth is reduced and circuit will have good selectivity. So when the bandwidth is less and the value of Q is more, the circuit will have good selectivity. Selectivity means it will ensure that the maximum gain is produced for the center frequency F naught. But if you compromise on the bandwidth is made broader, the quality factor will reduce and you will lose the selectivity for the circuit. Two cases you see. This is the frequency response of a circuit with lower Q. So bandwidth is large. This is the circuit frequency response of circuit with higher Q. You see how narrow is the bandwidth. The center frequency is going to remain same for both the circuits, but only thing, the Q factor is very much lower for one circuit and it is very much higher for the second circuit. So remember, Q factor is inversely proportional to the bandwidth, and more the Q factor, the better is the selectivity of the circuit. The lesser is the Q factor, you will lose selectivity over bandwidth. Okay, from the figure it is evident that a very high quality factor is required in tuned amplifiers to get better selectivity. So it is natural whenever you have a very high quality factor, the bandwidth is narrow and the selectivity is going to be very very good in your tuned amplifier circuit. Okay, so any doubts or queries you have in today's class?